So for this question, to prove congruence, let me just grab this from here, copy that, and we'll just go down over here. Cool. So I think your issue was with the letters instead of actual numbers to signify the parts of the triangle. So we're given that ABC is isosceles and the base of AB is just AB, cool. And the angle CAE, that angle here, angle 1. So let's just say let's just label this angle as X, and then this is equal to CBD, which is equal to, let's just say Y. No, let's be X as well, because this is equal, right? Cool. So in order to prove that DA and EB are equal, so DA, so we're trying to prove that this length, DA, and DB, and so EB, this length are equal. So in order to do that, we have to prove that these two triangles, so if I have a look, these two triangles, this one and this one, are congruent. Cool, so how are we going to start off? We will start off this by what I will do. I will draw the triangles out in a bigger way, so you can obviously see triangle. Cool, that's the first one. And the second one is something like this. Doesn't have to be to scale, remember? They don't have to be to scale. And I'm going to label all the points on this triangle. So it's D, A, and I'm going to call this M, and this is going to be M as well. So say I label this point M. I can't see that. Let's just say this is M. Cool. So with M. Cool. So now we should be able to see that these triangles are kind of similar to each other. Cool. So yeah, this is X, and then we have this is X as well. Cool. So how we begin the proof. So we usually like to look at the diagram and assess where the equalities are, right? So cool. So in this case, we're given that the big triangle ACB is isosceles, right? So we're given triangle ACB is isosceles. Cool. And that means that the base angles are equal, right? So that means that obviously this angle and this angle are equal, and that this length and this length are equal. Cool. So AC is equal to CB. Cool. So how we're going to start the proof off, just keep in mind that those facts that I just stated. We're going to start off the proof to prove these two are congruent. We're going to say in triangle ADM and triangle BEM. Cool. We're just going to tell them which triangles we're looking at, and then we're going to start our proof. So the first thing that they've given us is obviously that angle DAM is equal to angle EBM, right? Essentially, we talk about this, which is equal to X. Kind of, I already gave it the X notation. Cool, and we're going to give the reason, which is given. The question gave it to us. Cool, and that's the first proof. So that's just to give that a bit of context. This is an angle, right? Angle X. So X is the angle. So now we need to prove either with the congruency, we can either use our angle side, so angle on a side, or we can use our side angle side, or our side, but that might be tricky in this case. So we're more looking towards these two, right? Our angle side and side angle side. So for angle side, we'll need some more facts about this triangle. So what my intuition here is, okay. Yep, so it's a little bit tricky to see. Okay, so what's our next move? Our next move would be, okay. 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 I'm not sure if you've seen this yet, but let me just introduce it to you anyway. Cool. So we see that this angle here, these angles are actually equal. We call these vertically opposite angles because across each other, we technically have a line that's going across from each other, and technically this is 180 and this would be 180 minus that angle. So we're just going to say that these are vertically opposite. So I'm going to just say that this is we don't even have to give it a label. We can just leave it like that. Cool. And I'm going to say now angle DMA is equal to angle BME, which I don't know what, I haven't given anything, so I'm not going to say it's anything. And the reason is because they are vertically opposite angles. Vertically opposite angles are equal. This is the reason we give. Cool. You don't have to give too much of a reason. That's good enough. Cool. And so now we've proved two angles are equal. Now we just have to prove. So now we're going down essentially this path. So we've moved on from these two, and now we've got two angles. Now we just need one more side. So what side are we going to prove now? So it's just, now I have this angle is equal. So I'm just going to say this is equal to y, and this is equal to y. So I need to prove one side is equal. How am I going to do this side now? So this part is a little tricky. Which side can we look at? Exactly. Okay. If we look at the overall triangle again, if I'd rub everything out real quick. Oh, sorry, not that. I rub this out, this out, this out, this. Cool. So looking at the overall triangle, we see that there are some more things that we haven't identified. Like, yeah, okay, cool. So we noticed that there are some things we haven't identified, such as that this angle over here, right? This angle is technically, yeah, which is equal to this angle, right? But what about this inside angle, this angle, and then this angle of this triangle AMB? So this triangle that I'm talking about. What do we know about this triangle here? What can you see? I'm gonna let you have a look and then tell me. Cool. So if these angles are equal and this angle is equal, so the blue one is equal and purple one is equal across the sides. So this is equal to x, this is equal to x, this is equal to y, this is equal to y, right? Then obviously that means that this interior angle is also equal to each other. They're also equal to each other. That's what I'm trying to say. So let's just say this is alpha, right? So what does this mean? When base angles are equal, that means base angles are opposite equal sides of an isosceles triangle. Sorry, yeah, isosceles triangle. Cool. That's the important key to see that in this picture. So once you prove that these two angles are equal, i.e. MAB equals MBA. Cool. And then once you say that, you can prove that AM is equal to MB, which is our third and final element of our proof. So how this goes now, so our goal is to prove that, so now we're going to have some stuff here, right? We need to have some work here. So we're just going to come a little bit further down, and we're going to talk about how this triangle, so now we say looking into triangle, I think it was A and B, right? Which is that triangle that isosceles one inside, which is blue. We're going to look at it and say, okay, so we're going to say that this part's a little tricky because it's tricky wording it, right? But the more reasoning you give, the more authentic your response looks, okay? So we're going to say that angle CAB minus CAE is equal to AEB, okay? So no, EAB, cool. Okay, I'm not sure if you see that, but what I'm trying to say is CAB, so angle CAB less, so subtracting CAE, this is equal to our angle EAB, cool? Which is just simply, the reason for that would be because, it's not really the reason for that, it's just maybe intuition. Cool. And we already know that angle CAB is equal to angle, which one? Which we proved already. CAB is equal to CBA. Correct? CAB, yep, cool. And we know that also, we know that angle CAE is equal to CBD, which is equal to X, which we proved up here, remember? Which was given. Cool. And this one was also, I guess you can say, just given. Cool. And now we can say, therefore, angle EAB is equal to angle, so EAB, which is this one here, angle EAB is equal to angle DBA. Sorry, yeah, DBA, yep. DB, cool, which is what it's important. So now we can say, therefore, triangle A and B is isosceles. Cool. And now we can talk about its sides and say that MB is equal to MA. MB equals MA, right? And this is, you can say the reason for this is because opposite sides are opposite sides, the easiest way, opposite sides of isosceles triangle are equal. Cool. And now this is now part of our proof. MB equals MA. Because the lengths MB equals MA are also part of our triangle ADM and triangle BEM, so our original triangles. Now we have that these two lengths, MA and our MB, so that's essentially the blue part of this triangle in the photo, that and that are equal. Sweet. So now we have the full proof. We have our side. We have our two angles, which are up here, angle and an angle. So now we can say, therefore, triangle ADM and triangle BEM are congruent. Cool? Congruent means exactly equal, right? So they're exactly equal to one another. And the reason for this is our angle side rule. Cool? We can just simplify that with AAS. Cool? So there it is. The proof of this question. It's a little tricky, but I hope you can see how we can use the lettering as indications of length and angles.